In wireless, we need to send intelligent signal from point A to point B. Sounds easy. We're going to convert our ones and zeros into pulses of electricity, and then those pulses of electricity into pulses of information, pulses of signal that are there at a certain frequency, right? Okay. But the problem is that there can be interference. There can be jamming. There could be competition at that particular bandwidth at a particular time, and data could be lost. And so what we end up with in wireless is a whole lot of work devoted to how do we get it there anyway? Even though really we can almost guarantee that rarely will we just get the perfect transmission of signal from point A to point B. So what are our methods of getting around the problem? Well, we see that there are narrowband and spread spectrum technologies that are associated with sending a signal. Narrowband means that at any one time, it takes a piece of information, let's say it was a 1 or a 0, and it's going to send that over a narrow frequency, a single frequency. A spread spectrum is going to take that same piece of information and say it over a bunch of different frequencies simultaneously. Now, how are those both really designed to manage this? Well, frequency hopping spread spectrum is one method that is used in order to send signal over wireless in order to avoid the problem of jamming. And what it does is it sends out its information on a narrowband frequency, but then slightly changes which narrowband frequency it uses to send that information over time. And so it rotates using a semi-random configuration which frequencies it's going to use to send out these pieces of information. So we got A, B, and C there, and you can see that we're rotating how A, B, and C are being sent by adjusting the frequency. Notice frequency is on this axis now. Time is on the horizontal axis. So we're adjusting the frequency. Now, what we do here is we have a range of frequencies saying A, a range of frequencies saying B, a range of frequencies saying C. And so we're, instead of using a very narrow range for that frequency, notice how broad this is. That's the point. It is spreading all that information simultaneously, just trying to bludgeon its way through in order to deliver the signal. It actually requires less processing in order to coordinate all this information back on the other end. So frequency hopping transmission, not used nearly as often anymore. It was an early method for being able to convey information and get around the jamming issue. Direct spread sequence spectrum signal, DSSS, is much more commonly used as a way to provide that same goal, get around the jamming and be able to send out data intelligently using a broadband technology rather than time-based hopping to adjust how that information is being sent.